Slide. All right, so for today it's reflections. Let me show you what they're really like. Here is a typical y equals absolute value of x function, and you guys all know that that is a V shape. You're supposed to at least know that. And then that would lead to some points like 0, 0, 1, 1, 2, 2, and like negative 1, 1. Think that through. Does all that make sense so far? There's three different representations for things in math. You can just look at points, you can look at the way the graphs look, or you can look at the equation. Now, what do you think happens if I put a negative right there? Well, remember I taught you high vo? Horizontal on the inside, and vo stands for vertical on the outside. Okay, good. Then, is this high or vo? That's a vo. It's a vertical. It's a vertical reflect. Can you picture in your head what I'm going to do to the graph to vertically reflect it? Does that make sense? Okay. Now, what if the negative had been on the inside? Well, horizontal on the inside is a horizontal reflect, and it's weirder. If I put a negative on the inside, I want you to think about the math of this. Do you get, if I had a negative number and then I put another negative on it, won't really matter in this case. Why won't the negative in there matter? Because you're absolute valuing it. Do you get at the end, you're just going to make it positive anyway? I don't care how many negatives I put in here. They could put in 16 negatives. It doesn't matter because it's just going to come out positive at the end. So a negative on the inside won't do anything. But let me show you. I got your pass here. So when I reflect it this way, if you can imagine this thing rotating around, like I grab this with my hand and I swing it around like this way, do you get that the V is going to look exactly the same? Okay. It does look exactly the same, so it doesn't matter if there was a negative on the inside. Do you get that would also happen with a parabola? Everybody, please make a quick sketch of a parabola. Just a quick sketch. It's not a V shape. Similar. What letter is this more like? U. Same basic thing. Do you get that if I flip my U this way, vertically, it looks quite different. But if I flip it that way, it doesn't look different at all. Why is that? Well, because if I put it inside the parentheses, a negative getting squared is like it's not even there, right? Okay, and as opposed to if I put it outside the parentheses, then it will go on the answers because that squaring won't touch that negative. All right, so sometimes the horizontal or vertical reflections don't even do anything. All right, one more thing, I want to go back to that V-shaped one because I had the points here. I think we've established that only one of the, on the V and the U shape, the absolute value in the parabola, only one of the flips actually does anything. And that's the one on the outside. So I'm going to make this one a negative on the outside right there. And then this has to flip. So it's not here anymore. Now it's here. But what happens in the chart form when I do that? Can I trust that negative on the outside to just make everything the opposite? Yes. The stuff on the outside you can trust. But which numbers is it going to make negative? The X's or the Y's? The Y's. And I get people get confused on this, but Y equaled something, and then I made it negative. That negative is going on the Y values. So look, I just go into my chart, and I go negative, 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 negative. And now, negative 0, of course, is just 0, but see what I mean? So I can trust that negative to just make everything the opposite of the y's. All right. Stretch yourself. Your next test has a question, and I bet you there's going to be something like this on it. The 1 over x function. It's so easy. Not. It has been the bane of many higher algebra students, especially, well, only honors, because we don't even try this in regular. But if I said that we had shifted this one over 4 and up 3, does that make sense to you so far? Okay. Can you write the equation for it? You know it starts with 1 over x, right? Can you write the equation for it? And can you give me the domain? One thing at a time, just the equation. Hint, there's a 4 and a 3 involved. Row 1, person 6, Brooklyn, that is you. Which way did it get moved? It looks up to me. Up how much? Did you have a +3 at the end for that part? Okay. And then how about the move to the right part, which will be in there? Good. Is that +4 or -4? Be careful because you're on the inside where you can't trust things. -4 is correct. So there's your equation. But now how about the domain? The domain is left to right, but as you move from left to right, it's not negative infinity to infinity. So I'll just start with negative infinity. Because look, it goes further to the left. Can you finish the domain? These are the hardest domains to do. Hello, how are you?
Mr.
Having a big volleyball game?
Yes, we do.
Awesome.
When's your lunch break today?
I am done after 4th hour, but I don't stay very long because I usually go out to lunch.
Okay.
So if you want to chat after 4th, I'll be here for a bit.
Sounds good.
Cool.
I'll come find you then.
Yeah, awesome. Take care.
You too.
All right, so negative infinity until what's the first place where it doesn't work anymore? 4. See, as I'm going from left to right, I hit this wall right here. I can't go through that. I can't touch 4. Ooh, I can't touch 4. See? And then you need a little U for a union symbol. And then also starts at 4 but goes to INF, works just as well as the infinity symbol. And there you go. That would be the domain. Now the range, sometimes kids will be like, well, I remember these. The range is exactly the same. Nope. The range is similar, but would you please learn from what we did on the domain, and now do the range. Remember, the range is low to high. Okay, Noah Christensen, what's the range? Negative infinity until you hit 3 and then it stops working. Then? Very good. That's it. That is one of the hardest test questions. I haven't looked at the test, but I'm assuming there'll be something just like that. Because that's like the hardest kind of domain we have. You're in honors, so that's usually the kind we give you. Okay. All right. So let's move on to these reflections. I think they're pretty easy. It's just sticking negatives on them. See? All of them have a negative on them. What does that do? Well, it depends. Sometimes it doesn't do anything. Like when you square something that's negative, it doesn't even matter. And sometimes it does matter. So you tell me. Would it matter on this one? Nope. Would it matter on that one? Nope. Would it matter on that one? Yes, because the negative doesn't go away when you cube it. Would it matter on this one? Yes. I want a side note for just a second. You remember what 1 over x looked like? We just did that one. It was like this with the asymptotes here, and the graph was here and here. I want you to visualize, if I did a left-right kind of flip, that's a horizontal flip. Can you visualize where each piece would go? Then imagine an up-down flip. And do you realize they look exactly the same? Now let's talk about why. If you think about it, it makes sense in math that if I wanted to flip 1 over x and I wanted to put the negative on the outside right there, it'd have the same exact effect as putting the negative on the inside right there. See how math actually makes sense? No matter whether I put it on the outside or the inside, the answer is still negative. So yeah, it affects it. Either way. And it's exactly the same. I don't care if I put my negatives there or there. They come out the same. So yeah, the final answer would be something like this black line and not these anymore. All right, cool. So what else do we have to know? All we're going to do is just basically practice this. So let's do this first one across the top. Y equals x squared. I'm being really loose with it. It's just a u. I'm not being super accurate. I know you could if you had to. By the way, if you don't know how to be exactly accurate, you find exact points. Like 0 goes in and gives me 0. 1 gives me 1. 2 gives me 4. -1 gives me 1. And -2 gives me 4. And I could get exact points, but I don't need to. It takes too long. Negative x squared. Boop. Just like that. But I thought if you put it on the inside. I didn't put it on the inside. This one. That's on the inside. It's back to the normal one because the negative there doesn't matter. Okay, how about this one? Well, that's a V shape. Under this kind of a reflect, does it matter? Yes. Do. On this kind of reflect, it doesn't matter, so, well, you take the original one and it's still the same. How about square root? You remember what they look like? If you haven't got it memorized, memorize it. Looks kind of like that. Now, if your life depended on producing a square root graph, I know that's unlikely, but if it did, you just go off to the side. Your best friend in graphing, pump out a few points. 0 would go in and you get square root of 0 is 0. Square root of 1 is 1. Square root of 2, nobody knows that. Honestly, nobody even really knows that because the decimal goes on forever and never repeats. Okay? Square root of 3, square root of 4 works. Square root of 4 is 2, and then I could graph those points. 0 was 0, 1, 1, and 4, 2, and I'd kind of get a ramp. Okay. About a negative on the outside, would that matter? It would. It'd be a horizontal flip. Draw what you think it looks like. Horizontal reflect. Like that. Okay? Now this one is interesting. There's the smart people and then the really smart people. And then I want you to argue this one out with the kid next to you. If that's where it would normally be, what happens on this one? All right, talk to the kid next to you and see what you think.
Very interesting.
This is like the
Yeah.
All right. So, I totally get some kids saying, oh, it's just on the inside. And so therefore it's, oh crap, I just realized. Okay, this screwed things up a little bit. You know that blue one? That was on the outside. This one was on the outside. Those of you that knew the right answer, which was actually to flip it vertical on the outside, I didn't flip it vertical. You should have stopped me and said, Mr. Server, I think that you were doing that one backwards. I think you were afraid that you were wrong and you didn't say anything. But you were right. Who had that way and then just kind of trusted me? Don't trust me. Okay? If you could just be like, wait a minute, can you explain that one again to me? I would have been trying to explain it and then I'd be like, oh, oops, I screwed up. Okay, sorry about that. So back to this one now. Here's the normal square root graph. What happens if you do a negative on the inside? Well, I get a kid going horizontal on the inside, horizontal reflect. It should probably look like that one. And then I get another kid saying, but wait, you can't have negatives under square roots. So there is no answer. What's right? Is there an answer and it's on the board, or is there no answer? What do you think?
No answer.
Okay, so I heard no answer, and then what? So you're going with no answer also? All right. Well, how could we break the tie? We got one kid, actually both kids that spoke up said that there is no answer. How could I prove that there is or that there isn't? I mean, other than just telling you stuff, how could I prove it?
X could be a negative.
So what do you?
So then the square root would be positive.
So are you going to go to the XY chart, which is a different way to write the equation and very smart? I think that's a good idea. So you're saying I could put in a negative number for X, and then the negative will cancel the other negative, and then I won't have the square root of a negative anymore. All right. Give me an example.
Negative 4.
So if I put in negative 4, the negative 4 goes here. And all of a sudden I have the square root of positive 4, which is 2. It seems like it's working. And that is the right answer. This is the right answer. I get why people see that negative and they're like, oh, I caught an exception. You can't have square roots of negatives. But if you use negative numbers for the x, then the negatives will cancel and it'll work. Okay, so that one does work. It is not a fail. And another way you could have tested it is if you would have graphed it. You just use a graphing calculator and graph y equals square root negative x. And it would have given you that. You'd be able to see the graph. If you can see the graph, then it worked. It's not imaginary. All right. If you ask it to graph square root of negative 25, it will not, because it'll be like, that doesn't exist. But square root of negative x, that looks like that. Okay, let's move on. I just think these are good from the perspective of, do you know what that looks like? Because I've got it memorized, and I think about half of you have it memorized. Sketch what you think that looks like. If you have no clue, do you get if your life depended on it, you'd make some points and you connect the dots? I put in 0, you get 0. Put in 1. 1 to the third is 1. 2 to the third is 8. 3 to the third goes way off the graph, so I'm not even going to bother. Negative 1 to the third makes negative 1. And negative 1 to the third, negative 2 to the third makes negative 8. And if I graphed all those points, forgive my wiggly hand there, but it looks something like that. The way I'd like to think of this is it's sort of like a parabola on this side, except steeper, because it's not x squared, it's x to the third. And yet on the other side, the negatives don't get canceled out. So then it's like a parabola going down on this side. It's like a parabola going up on one side and a parabola going down on the other side. What happens to this negative? Does it count? Does it matter? Yeah, because the third power doesn't take it off. So then how do you flip something vertically? Well, it's like one of these again where If the negative had been on the inside or the outside, it'd look the same. So think of this and you think, oh, if I flip this horizontally, what would it look like? And then if I flipped it vertically, what it would look like, and it looks the same. And that's because math-wise, I don't care if I put the negative there or on the outside like that, it comes out the same. That's why the answers look the same. All right, and how about the 1 over x? Well, we've done that so many times, it's kind of getting pretty easy, I hope. But what does it look like when you have a negative? Well, again, whether it's on the inside or the outside, it'll look the same. Like that. Okay. Can we combine reflections and translations? Of course we can. So what if we had this? Then that's been moved up 7. That's the easy part. And reflected, and the way you would want to say it on the test is not up, down, or left, right. You use high or low. What's this one? Horizontal on inside or vertical on outside? That negative? The negative? Is that?
The negative is.
The negative. Talking about the negative. That's on the inside. So officially you would say that this has been reflected, but what way? Horizontally reflected. And I would accept those abbreviations. H for horizontal, R, E, F for reflection. Horizontal reflection. And yes, you could say that that 7 is a translation in the vertical direction, but then it's using such complicated words, it'd be just easier to say up 7. So, what if they got really intense and you had to graph this on a test? Negative, absolute value of, negative x, absolute value, minus 4. Do you think I'd want you to graph the V shape and then flip it this way and then flip it that way and then move it? No. I would want you to know that that happened. It had a horizontal reflection, a vertical reflection, and it moved down 4. But to actually graph it, I'd use your best friend in graphing, which is the XY chart. Get used to that. The XY chart, your best friend in graphing. Find me some points, and then we will graph them. How many do you need? Well, 3 is barely enough, and that's only if you got the vertex. I did show you yesterday how to find a vertex, and I know this one's vertex. I don't know if you do. But you can find enough points, and if anybody gets enough points and it's like you can't tell where the graph is after I make those dots, then you got something wrong. I mean, like, you should be able to tell. If you have enough dots, you can tell where the graph is. So if you can't tell where the graph is, you don't have enough dots yet. Okay, so I'm sticking in 0, and I get, well, 0 on the inside, and then it's all 0, and then minus 4. 0 gave me negative 4. Who had 0, negative 4? You were correct. What if I put in a 1? Negative 5 is correct. If you didn't get that, go back and check yourself. What if I put in a 2? What'd you get? Negative 6. How about if I put in a negative 2? Again? Yeah, because look, if I have a negative and an extra negative in here, it doesn't matter how many negatives I put in here. It's going to come out as 2. And then it becomes negative 2. And then you put with the negative 4, so it's negative 6 again. That's okay. So now, is that enough points? Well, probably. Let's graph it. 0, negative 4, it's down there. 1, negative 5 means over 1 and down a little bit more. Over 2 and down 6. 2 to the left and down 6. Yeah, that feels like it's probably like that. Now, I want to remind you that if I wanted the origin from this, sorry, not the origin. If I wanted the vertex from this, I would go like this. And I'd go, oh, it's like there's a 0 in here because there's no other number. So the vertex is 0, comma, -4. Look at that. It's right there. It's right there. That was the vertex. That, comma, that. Get used to those vertexes. It's really handy for the graphing part. Okay? See, I had these red dots. Could you have connected the dots? Yeah, it's pretty easy. Okay? So, if I ask you to describe them in order, all of a sudden the order matters. Let me explain how to do the right order. To do the right order, in my opinion, this is actually an opinion thing, because you can do it both two different ways. I think the easiest way is, wouldn't you agree you've been told a million times that on a complicated math problem like this, that you'd start on the inside? Wouldn't you agree that you always start on the inside of complicated math problems? I've done more than you have because I've been doing this for a long time, and yeah, you always start on the inside. So that's where I think you should start to do the order. Now, it can be okay to start on the outside of the function. I know that's confusing, but it's true. It's one of those inconvenient things. I'd rather just say there's only one way and it's my way. There's actually two ways. That does not mean that any order goes. This will be one of the most marked wrong questions on the test, is what order should you do this in? Okay, so pay attention here. All right, on this one, I said start on the inside. Was there any changes on the inside? Yes. Can you use the word vertical and horizontal and say the change correctly to me? Horizontal what? Horizontal reflect. Good. And then the other change is up 7. Now, I say, and I want you all to start on the inside. Now, if there's one kid that goes rogue on the test, I'll try to adjust my brain, but I want you to start on the inside, because honestly, that's how you do most math problems, is you start on the inside. All right, let's go to this one, and a ton of people are going to get the order wrong. Because why? Because we're in the inside, where everything gets confusing. There's two things that happen. Do them in the right order. First thing, the second thing. Think it through. All right, compare with the kid next to you and argue it out.
Left 4 and then flip over the
Vertical is like vertical is like this, or horizontal is like no, like we did this.
All right, now, the order we can argue about in a second, but would you agree that one of the things is that you're going to go to the left 4?
Yes.
Yep, okay. And that's already kind of opposite of what you would think, because plus 4, positive numbers are on the right, so it seems like you should be going right, but you go left. So left 4 is one of your things. Another thing is that there's a negative on the inside, and that's a horizontal reflection. Would you agree with that? Now, which one's first? Who wants to argue the case for the reflection being first? Just give me your argument that the reflection should be first. How about who wants to argue the case that the left 4 should be first? Yes?
It's on the inside. Correct.
All right, so so the left 4 is on the inside of the parentheses, and therefore it should go first. All right. Now, you've heard one side of the argument. Decide for good, what do you think is first? Do you think it's the left 4, or do you think it's the reflect? What do you think?
I think you reflect first, so then you can like
Why?
move it after.
Okay. I will admit that just from the graphing perspective, it would be easier to reflect it and then move it. I agree with that, but that's not necessarily an argument that that's the right way. I'm not saying you're wrong, I'm just saying prove it to me. You think that. He thinks that. Convince the average kid in the back that you're right. It's kind of like what we're doing in the election is people argue their side, and then somebody has to decide. All right, I'll tell you. And this really messes with your head because everything's opposite world. What you said was that this is on the inside of a parentheses, and parentheses go first. Unless you're doing opposite world. See, that's actually the best argument for why the negative should be first, because normally isn't the inside of a parentheses first? So then it's not first. That reflection should be first. Final answer. Horizontal reflect is first. And the left 4 is second. That is really a mind bender. It's opposite, because it's opposite of the opposite of the opposite. It's all so crazy. Okay. That negative is a multiply. That's an add. And other kids will go, yeah, but multiply is supposed to come before add, and so therefore it shouldn't be first. But they're avoiding the fact that there's parentheses. And in the whole PEMDAS thing, isn't parentheses the very first thing you're supposed to do? See? So that would normally have to be first because it's in parentheses, so then it has to be last. Does that make sense to you now? All right. Maybe you'll just always get them wrong from now on. I doubt that. All right, this one. That 3, it's so confusing because there's a negative right next to it, but do you agree that the 3 is not the negative thing? All right, the negative thing is on the x. So now I also get this. People are like, oh, so the negative is in the inside of this thing. No, it's not. That negative is not on the inside. The inside is by the x. I'm going to start saying inside with the x, because if it was in there and there was a negative, it would be different. That negative is on the outside. That 3 really ought to be moved to the end and be a positive 3. And then it would be more obvious that that negative is on the outside. Now, given that, I said to start on the inside, but there's nothing to do on the inside. So then you move to the outside. When you're on the outside, is there an order you have to follow? Yes, there is. You will screw it up if you do it in the wrong order. So, should that negative be first, or should the plus 3 be first? I'll give you a hint. This is a negative 1 being multiplied, there's a dot in there, by that parenthesis. So, take a stand. Step 1, step 2, there is an order. The order matters. About 25% of kids get their order problem wrong on the test. All right. Dice and test. You should have got it. Row 2. Person 2. Say your name to me. Anwishan? Anwishan. Thank you. Anwishan, what do you think is first?
The reflection.
The reflection. Can you prove it to me? You had a 50-50 chance.
According to what you said, PEMDAS, and you can trust the outside.
Nice. PEMDAS on the outside. It's choice between multiply or add. Multiply is first. But I thought we didn't follow PEMDAS. It's because we're on the outside. You can trust the outside. You follow normal order. You follow things like normal on the outside. So Yeah, reflect is first. That's the normal order. And then the up 3. I refuse to make kids say vertical translation of 3, but it is. Up 3 is fine. All right. Now, what if you had to graph it? Well, your best friend in graphing kicks in. I would not graph this, then flip it, then move it down 5, because even though you might roughly get an idea of where it is, kids do that on the test, they get it marked wrong, because even though it's generally in that neighborhood, that's not the answer. The answer needs points, so use your best friend in graphing the XY chart. Find a few points. Be careful. When you put them in, you're putting them in here. That negative is not inside with the X. And yeah, it's going to be sort of in this neighborhood, but don't ever try to graph that way on the test. I can't give you credit for that. So find a good 3, 4, sometimes even 5 points. Connect the dots. Easy peasy. All right, so I would have picked 0 because I just always pick 0 first and see if it works nice. 0 does work nice because that whole part's 0 and then minus 5 is minus 5. Then I put in a 1. 1 squared is 1. Then you make it negative. Negative 1 minus 5, negative 6. Then I put in 2. 2 squared is 4, make it negative. Negative 4 minus 5, negative 9. Then I put in a negative 1. Why? Because you want something on this side of the graph, don't you? So I'm going to put in a negative 1. Negative 1 squared is actually going to act just like regular 1 because it comes out positive 1. Then I make it negative. Then I put the negative 5 with it. It's negative 6 again. Don't be dismayed if you get 2 answers like that. That's fine. All right. And then if I actually graph those, I'll have some to the left side of the graph because I put in a negative for this. And now negative 1, negative 6. I actually hit that pretty close. And 0, negative 5. Well, pretty close. 1, negative 6. Yeah, not too far off. 2, negative 9. Ooh, I was definitely off on that one. And wait a minute. I think I just made a mistake. Yes, I did. This red dot actually is more like here. So, final answer is this red one. Do you get why I tell kids that they shouldn't just kind of rough estimate? I mean, that was off. It was in the right neighborhood, but you have to have exact points to get these right. All right. That's all I got for you. So now, let's see if we can find that worksheet. Or is it a Schoology quiz? I will know within seconds here. It is a worksheet. And as usual, it's a little bit too big. And so I'll tell you some that you can skip. Okay. 9 and 10 are the hardest thing and really important. So I'm going to skip a bunch of the other ones. I'm going to say you can skip numbers 4, 5, 6, and 7. You can skip 4, 5, 6, and 7. Let's do the very first one. I like to say y instead of f of x. Negative x to the third. If I had to graph that, I would go right to the points. I would not try to sketch it and then flip it. I would go right to the points. I would stick in like 0 and get 0. I'd stick in 1 and get negative 1. I'd stick in 2 and I'd get negative 8. 0, 0, 1, negative 1, 2, negative 8. Oh, I'm getting the idea. I think it's going to look like this. And it does. But you need exact points. Now it wants the domain and range. Okay, domain is left to right, and this one is going forever to the left. I know it's going up, but it's also going left. This one's also going right. So the domain on this one, negative infinity to infinity. And you always have parentheses on infinities. The range goes from low to high, and it's infinitely low to infinitely high. There we go. I would make an XY chart for all of these. All right, I did give you a whole bunch to skip. So now let's jump into number 9. Look at problem 9 with me. Number 9. It says equation for the quadratic function. Out of all of those weird looking shapes, the quadratic is this one. Would you agree that it is upside down and goes through the point 3, 1 as its vertex? Well, first off, you can say, well, it's a quadratic, so it's x squared. Then you have to ask yourself, did it move to the right? Yes, it did. So I guess I should put something on the inside then. Did it move up and down? Yes, it did. Did it get flipped? Yes, it did. So I can go, it moved to the right 3, minus 3. It moved up 1, plus 1. And then it's upside down. So where does the negative, careful, where does it have to be, inside or outside? Outside. And there's my equation for it. See how you can put that together? You knew it was x squared because there's a parabola. All right. You can assume arrows on the ends of those graphs except for on the square root. The square root can't just go up forever in both directions because the square root, you can't have negative numbers inside it. So only the square root doesn't have arrows. Other ones have arrows on the ends. Okay. So I totally understand that you might need some help, especially at the end. You can always come on up and ask. I want to help you. You just have to ask. And that's all I got for you for today.